Hello and welcome back to Humanoid Leader series. Today I'm thrilled to be joined by Daniele Pucci, the CEO at Generative Bionics, and today we're going to be discussing the launch of their new GENE01 humanoid. Daniele, thank you very much for joining me.
Thank you for reaching out.
Can you start by telling us a bit more about Generative Bionics, its origins, and your role as the CEO in shaping the company's direction?
Yeah, so Generative Bionics born as a spin-off of the Italian Institute of Technology. So basically, we've been working more or less 20 years on humanoid robots, starting with iCub. I mean, one of the first versions released back in 2009 in a famous project called RoboCub, led by Giorgio Metta, Giulio Sandini, David Vernon. And basically, iCub was a very nice story. We produced, built, also maintained more than 60 humanoid robots around the world. And that was between let's say, 2010 and 2020. Then always at the Italian Institute of Technology, we've been working on the ErgoCub. ErgoCub stands for ergonomy because we had this collaboration with INAIL, the Italian Institute for Work Accident and Prevention, and the goal was, let's make a robot that could help the future workers reduce their risks while doing physically heavy tasks. So we also produced ErgoCub and then distribute also the humanoid robot in few copies. And then back in 2024, we were able also to work on IronCub and to make it fly. So basically, we are the only ones somehow that have also this background of flying jet-powered humanoid robot. So it was 2023, more or less, and we realized that all the technology that we've been building needed a step towards industrialization for vertical segments. And we started the story of Generative Bionics. So it was not really quick in order to close it. The fundraise and the entire initiative took more or less 2 years. And then we were able to launch the fundraise, the $80 million fundraise that was closed back in December. And now Generative Bionics is fully operational starting from the 7th January 2026.
Perfect. Now, recently at CES, you unveiled your GENE01 humanoid concept. What were some of the key design and technology principles behind GENE01?
Yeah, so basically, some of the fundamental differences of GENE01 with respect to possible other humanoid robots that you see out there are around our concept of human-centric physical AI. So we really believe that humanoid robots have to stay around people. I mean, you might see many humanoid robots out there. Some videos actually where humans just kick the humanoid robots, or humans not appearing into the scene. Instead, we believe that humanoid robots have to somehow collaborate with human beings for an effective integration of technologies that at the end need to serve humanity. So this is our standpoint, and also our differentiators are built on top of this, we think, different philosophy. So, for instance, one of the things that we're working on extensively was these whole body tactile sensors that we inherited from the iCub project and also the ErgoCub. And these whole body distributed tactile sensors, we believe that is fundamental in order to enable effective physical human robot integration. Then the other differentiator resides on how we design and also simulate humanoid robots. So over the last 4 or 5 years, we have been working on a generative physical AI method, which can connect the properties of the material of the robot to the amount of compute that you need in order to express a specific AI functionality of the robot. So just to make you examples to help the understanding. So while we walk, the distribution of masses inherently impact also how much computation you have to do in order to make the robot walk. So there is a strict relation between the physics of the robot and the optimal physics of the robot with the AI itself. So we've been working on this differential generative physical AI, which allows you to generate in one shot both the body and the AI of the robot. And then there is absolutely also the concept of, let's say, the design of the robot. I mean, one of the things that sometimes people do not understand is that robots need to be accepted in order to be sold. And acceptability is not something that you can simply neglect. I mean, there are many examples of technologies which have been built and then they have not been accepted, so they died instantaneously. So for us, really, acceptability has been translated into grace, beauty, and also safety. So with these three elements, the importance of design is fundamental because it has to express the right concepts to humans that have to integrate with humanoid robots. And then we see clearly the design, as I was saying before, as part of the intelligence because it's a sense of the robot itself. Lastly, we think that in order to integrate humanoid robots with humans, also humans need to be perceived. I mean, that's why the other different approaches that we take a system perspective at the application level by considering humans. So we often give wearables to humans so that we can perceive the fatigue of the human, and this fatigue is yet another sensor of the eye of the robot so that it can react in the best way for human-robot integration.
Perfect. Now, you kind of touched upon that briefly in your previous answer, but it seems that generative bionics, you place a strong emphasis on industrial and real-world applicability. Which use cases or environments are you going to be prioritizing first? And what will make your humanoids or your GENE01 particularly well-suited to perform those tasks?
Yes, so first of all, it is important to say that we see GENE01 as a platform rather than a single humanoid robot. I mean, many companies out there are trying to approach the problem of humanoid robots by building one robot that does it all. We think that this doesn't work out. And just to make concrete examples, you cannot think that the same humanoid robot that is in a ship performing welding tasks is going to be exactly the same as a humanoid robot that has to deal with a patient in an hospital. So, and this is not only common sense. If you see the regulation, okay, for instance, in Europe, it's clearly the case that medical devices have a different path than common manufacturing devices that don't have to enter into an hospital. So our view is that humanoid robots need a degree of customizability in order to be effective and then at the end to be bought by customers that want to have a real and measurable added value. So we see GENE01 as a platform from which we can drop out specific humanoid robots that meet also different certification criteria for the verticals at hand. So the first vertical that we started addressing was manufacturing and more precisely welding with Fincantieri. Fincantieri is one of the largest ship builders in the world, and they're looking for somehow automation systems in a very safety critical environment, so where there is no flat terrains, where there is stairs, and where you have to take the welding machine and navigate complex environment. So the first vertical that we are looking at is manufacturing. But then we also see other verticals. We are addressing it right now, logistics, just to make an example, surveillance, another examples, and then healthcare. I mean, healthcare, especially in Italy and Europe, deserves really specific solutions. I mean, you can think of a humanoid robot there, which has a plenty of applications. So you can put the robot at the entrance to accept patients when they come, as an interface between customer and service, which is basically healthcare services, and then the robot can basically start becoming closer and closer to the patient. So it can do micro logistics in the hospital. It can then also take patient, help them walk. So there is a large variety of application, and the closer the humanoid robot is taken to the patient, the more complex the certification itself. So it's a perfect environment also to define the next generation certification layer that you need to have in order to sell the humanoid robot.
Awesome. Yeah, so one of the recurring challenges in humanoid robotics seems to be translating intelligence into real physical action. From your experience and the team's experience, what are some of the hardest problems to solve in allowing that to happen?
Yeah, so also here, there are many companies that are approaching the problem with one model does it all. So if you have a little of experience, you clearly understand that a single model that does it all, it's not always the right solution, especially when you have to meet strict KPIs defined by the customers that at the end it is the only thing that really matters. So we are building composable architectures that can also integrate different submodules, some of which for sure they're based on our data-driven models for that basically we build using our wearables, doing imitation learning, just to give you examples. But when you go down to specific subset of actions, you may also go model-based techniques. So, we didn't fall in love completely with all these data-driven approaches. We really want to have a composable architecture which allows us to use the model that we need for the problem at hand. If you look at the challenges, here are many, and here I share clearly the vision that one of the challenges is manipulation. So having the right degree of dexterity for the given task, it's going to be a challenge. But once again, our approach is that we generate the right mechatronic solution for the problem at hand. So we have this vision of building general purpose humanoid robots, but at the same time we want to build a sustainable company which can drop out specific solutions that can meet the customer KPIs.
Perfect. So with a really large engineering team drawn from many years of experience, as you mentioned earlier, from IIT research, how are you finding the balance, or kind of balancing, deep technical expertise with the practical needs of industrialization, certification, and productisation?
Yeah, so in this case we are really focused and pragmatic, I have to say. So first of all, right now we are 85 people growing up quickly. We have to hire more or less 150 people this year, and we have an agile project development technique that we've been experiencing and practicing for years. So the entire company is based on agile, and we have now 8 teams focused on different robot functions. So we have the team designing the GENE, we have the team whole body. So we have a team completely focused on the whole body design of the robot, which is also doing simulation and co-design with our generative physical AI. Then we have also a team that is concerned with the manipulation and hand dexterity. And then we have a team that is focused on the AI, digital twins, locomotion, and all these teams are basically developing functions. So these are horizontal teams that are cross-functional teams, integrating competence in AI, mechanics, electronics, design, and etc. So in these teams, there is also a certification expert. So because you have to be sure that once you are composing the puzzle, everything meets the certification criteria because you have to sell the robots. So we are basically building horizontally these functions, and then we have vertical product teams that integrate all these functions into the specific gene for an application, for a focused application. So just to give you an example, we are now starting the product team for the welding application. So GENE01/W, which is the welding line, it's going to be a vertical team that basically takes all these horizontal functions and then differentiate a solution which is going to meet the KPIs defined by Fincantieri.
Just wanted to touch on what you mentioned there in your previous answer, if you don't mind. You mentioned the split at Generative Bionics in terms of, you know, whether it's between dexterity, hardware, etc. What is the split between your staff there? Is there a stronger focus on, you know, dexterity, for example, or is it fairly even across the board?
No, I mean, the problem is that this kind of, I mean, the humanoid robotics is a, let's say, multifunctional story. So you have to keep the right balance among all the components because the body is going to be as important as the, let's say, AI model. So let's say that more or less we have 10, 15 people for each team, and then we have 3 teams, however, only dedicated to either embodied AI or motor control AI, so reinforcement learning more precisely. So we have more or less 35 people working on AI if you take them all together, but they're split into 3 teams. So in this perspective, we try to stay close to the two pizza team role. That with a couple of pizza you should feed the entire team. Yeah.
Nice. So earlier you mentioned, you know, that you'd raised over 70 million euros. Congratulations, by the way. You know, with participation from those such as AMD. What strategic value do these investors bring, obviously beyond capital? And how are these partnerships, you know, shaping your technology strategy?
Yeah. So I mean, when we structured the fundraise, really the mantra was let's stay strategic. So we were not only looking for money, we were looking for collaborations which helped us scale not only, let's say, at the application of the robot, and, but also at the technological fundamental level. So that's why, for instance, our investors are composed by clearly institutional investors, because we come from the Italian Institute of Technology, and at the institutional level, we wanted also to have a flywheel, because we are basically the most important initiative for humanoid robotics in Italy, and we believe also among the most important in Europe. So we wanted to have this flying wheel at the institutional level. And then we have the technological partners like AMD and Tether. So AMD is a fundamental partner because it gives us the entire compute at the technology level, so we can go to the edge electronics, working with them on the protocol and working with them on optimizing GPUs and CPUs, and also the cloud computing. So for us it was perfect because it had this continuum of platform. So then Tether is also investing a lot on QVAC, which is their AI subsidiary. So with them, we are doing a great work in optimizing models for physical AI. And then we have ENI, which is basically another ENI Next, another investor in the oil sector, fundamental for us to find use cases and also computation infrastructure. And then we have Duferco, one of the biggest steel manufacturer in Europe, which is basically also helping us defining the use cases. And then we have another investor, Roboit, which is a here an incubator in Italy, always funded by the same institutional investor that we were mentioning before. So a very important set of strategic investors, and each of them had not only somehow the economic contribution, but also a strategic component for deploying humanoid robots.
Perfect, thank you. Now, Daniele, what excites you the most about the next phase of humanoid robotics? And more importantly, how do you see generative bionics contributing in that moment when eventually, we see humanoids working alongside humans?
Yeah, I mean, right now our exercise is to scale our solutions towards the verticals. So right now we are completely focused in taking the humanoid robot from the proof of concept and then making the pre-series, and the pre-series has to meet criteria for the customers that right now have specific problems. So we have to somehow take a step from the nice narrative that AI is going to solve all physical problems. Well, physics is there, you cannot neglect. Sometimes it is a barrier. So the so-called sim to real gap is still there, and the digital twins that have been building for years still require a phase where you need the real data. So there is something that basically we are facing, and once you somehow get out from the lab, you enter into the real workplaces, that adds a degree of complexity that was much different than that you had into the lab. So that is one of the challenges right now. So humanoid robots at the lab are cool. Humanoid robots dancing are very cool. Entertainment has been solved basically. But right now we have to find solutions for humanoid robots that can bring real measurable added value. And in order to get that, you have to add a degree also of manipulation. So mobile intelligent manipulation is going to be a fundamental step in order to sell humanoid robots that can clearly add an added value for the customer. So our perspective in that is that we want to generate humanoid robots that meet specific KPIs for the different verticals by generating at the same time optimal bodies and AI. So that's why we've been working on that extensively, and we see the biomechanics of humans as a preconditioning of this AI, which generates humanoid robots and also models. So what we like of our approach is that we are trying to generate humanoid robots by letting the AI pick up the mechatronic solution, and the humanoid robot is an output because you are preconditioning the AI with the human solution. And we see that as a way in order to get new product automatically as the fundamental technology which acts as a constraint basically changes. Because I mean, you can imagine that right now we have, I don't know, brushless motors or QDD motors, or you have the planetary solution for the gearboxes. So all these mechatronic solutions act as a constraint for this AI that has to generate the body. So once these constraints change, then automatically you get new solutions, till to the vision that at the end we will most likely have also muscle-like actuators, so that you get the new humanoid robot generated automatically by this AI, which also produces the motion capabilities, the interaction capabilities, so the brain of the robot. So this is basically our perspective. We want to work on parametric physics and generative physical AI methods that generate at the same time bodies and minds by seeing the technology as a constraint and then taking humans models as preconditioning.
Well, Daniele, thank you very much. It's been an absolute pleasure. And before I let you go, could you just let our audience know how they can learn more about Generative Bionics?
Well, you can. We are in Genoa, Italy, a very nice landscape, or just visit our website, which is gbionics.ai.
Once again, Daniele, thank you very much.
Thank you.